Section 5.5, Solving Rational Equations. Rational equations. Previously, we have worked with expressions, but now we'll open the door to equations, meaning there's an equal sign. When there is an equal sign, we have a lot more opportunities to work with the problem. A rational equation is an equation containing one or more rational expressions. Here are some examples. So we have problems like 2x minus 7 divided by 4x plus 5 divided by x equals 8. To solve a rational equation, recall that one way to clear fractions from an equation is to multiply both-sided equations by the LCM, which is our lowest common multiple. Solving rational equations. To solve rational equations, the first step is to clear the equation of fractions. To do this, multiply all terms on both sides from the equations by the LCM of all the denominators. Then carry on the equation solving process as discussed in previous chapters. So in this first example, we have solve 2x minus 7 divided by 4x plus x plus 5 divided by x equals 8. So this 8 actually has a denominator of 1. Okay, so what would be our LCM? So all of our fractions can be covered by 4x and x. 1, we don't need to write 1, but if you like to, you can. Let's go ahead and multiply both sides by 4x times x, so that we have 2x minus 7 over 4x plus x plus 5 divided by x equals 8. And let's multiply the right-hand side by 4xx and the left-hand side by 4xx. Now, let's go ahead and distribute that by each term in our equation, so that we have 4xx, or x squared, times 2x minus 7 divided by 4x plus 4xx by x plus 5 divided by x equals 8 times 4x times x. Okay, here we see that 4x and this 4x cancel, right? So we're left with x times 2x minus 7. Here, 1x and 1x cancel, so that we're left with 4x plus 4x times x plus 5 is equal to, and nothing cancels on the left-hand side. So we have x times 4x squared. All right, let's go ahead and work it out. So we need to distribute this x. So x times 2x squared and x times negative 7. We get 2x squared minus 7x. And then we have plus 4x squared. And then plus 20x is equal to 8 times 4, 32x squared. That's so cool. Now that's something we can work with. So that we have 2x squared plus 4x squared, we have 6x squared. Negative 7x plus 20x, we have plus 13x equals 32x. Okay, let's make it equal to 0 so that we can solve. So minus 32x squared, I forgot the squared, minus 32x squared. We're left with 6 minus 32, we get negative 26x squared plus 13x equals 0. You can go ahead and factor. Have a common factor of 13. You can factor out a negative 13 and an x. So negative 13x, we're left with 2x minus 1 equals 0. So we can set each factor equal to 0. So we have negative 13x equals 0 and 2x minus 1 equals 0. So that we're left with x equals 0 and x equals 1/2. Checking possible solutions. When we multiply all terms on both sides of an equation by an LCM, the resulting equation might yield numbers that are not solutions of the original equation. Thus, we must always check possible solutions in the original equation. So let's go ahead and do example 2. Solve 2 divided by 3x plus 1 equals 1 over x minus 6x divided by 3x plus 1. So I don't have your steps outlined like I did in the previous problem, but still, our first step is to find the LCM. So looking at all of our denominators, if we write down 3x plus 1, we got that accounted for. Now we need to worry for an x, so that we have an LCM of 3x plus 1 times x. So let's go and multiply our LCM to both sides, so that we have 3x plus 1 times x times our left-hand side, which is 2 over 3x plus 1, and then 1 over x minus 6x times 3x plus 1 times our LCM of 3x plus 1 times x. Let's go ahead and multiply that in. So we take this and multiply it by each term in our parentheses, and luckily things will cancel out, so that we have 3x plus 1 times x times 2 over 3x plus 1 equals 3x plus 1 times x times 1 over x minus 3x plus 1 times x times 6x divided by 3x plus 1. Now here's the fun part. Stuff should divide to make 1. So this 3x plus 1 cancels with 3x plus 1. Our x's cancel out, and again our 3x plus 1 cancels out. So what are we left with? We're left with x times 2 is equal to 3x plus 1 times 1 minus x times 6x. So that we have 2x is equal to, we distribute in the 1, 3x plus 1 minus 6x squared. Okay, let's set it equal to 0. So let's move that 2x minus 2x, and we're left with 0 is equal to negative 6x squared plus 1x plus 1. Okay, let's go ahead and factor. So we have to factor using the AC method. We have our A times C. We want sums that add up to B. A times C, we get negative 6, and our middle number is a 1. You can get numbers that multiply by negative 6 add to be 1 with a 3 and 2. Let's make the 2 a negative, so that Negative 2 plus 3 is 1. We have negative 6x squared plus 3x minus 2x plus 1. We group our first two and our last two, so this factors to be 3x. We get a negative 2x plus 1. Here we can factor a placeholder negative 1, so we get negative 2x plus 1. So this is 3x minus 1 and negative 2x plus 1. So our answers are 3x minus 1 equals 0, negative 2x plus 1 equals 0, our answer is 1/3. X is positive 1/2. Okay, let's go ahead and check our answers. So to check them, we have to use our original problem. If you check them, one of these will not work out. So let's go ahead and check them. So let me erase some work. Let's check that first answer of positive 1/3. So I have 2 divided by 3 times 1/3 for x plus 1 equals 1 over 1/3 minus 6 times 1/3 times 3 times 1/3 plus 1. Alright, well 3 and 1/3 is 1. So we're left with 2 divided by 2 plus 2, which is 2, equals 1 divided by 1/3 is 3, minus 6 times 1/3 is 2, 1/3 times 3 is 1, 1 plus 1 is 2. So we have 1 is equal to 3 minus 1. No, that's not true, right? 3 minus 1 is 2. So this one is false. We got a false answer already. I'll leave you to check 1/2. I'll do example 4 with you. So let's begin by finding our LCM. Our LCM needs to consider all of our denominators. Now, our denominator for that x squared minus 9 factors to be x plus 3, x minus 3. So the LCM that will cover all those denominators will be an x plus 3 and an x minus 3. Since we see we have an x plus 3 here and an x minus 3 here, and x plus 3 and an x minus 3 will be covered in both of those. Let's multiply both sides by our LCM so that we have x plus 3 x minus 3 times 8 over x plus 3 minus 6 times x minus 3 is equal to 2 over x squared minus 9 times x plus 3 x minus 3. Okay, well, let's distribute it into each term in our parentheses. So that we have x plus 3x minus 3 times 8 over x plus 3 minus x plus 3x minus 3 times 6 times x minus 3 is equal to 2 times x minus 3 x plus 3. I'm writing that instead of x squared minus 9 times x plus 3 x minus 3. Alright, stuff should divide to make 1. So this x plus 3 cancels with this x plus 3. This x minus 3 cancels with the x minus 3. And the x plus 3x minus 3 cancel with the x plus 3x minus 3. So what are we left with? We're left with x minus 3 times 8 minus x plus 3 times 6 equals 2, and that's it. All of our other stuff canceled out. So if we multiply this, we're left with 8 times x minus 3. So I have 8 times x is 8x, and 3 times 8 is 24, so I get negative 24. Let's distribute in the 6. So let's multiply in that 6. I can multiply it by that 6. So I have negative 6x minus 18 equals 2. All right, let's clean it up. We can add up our x's. 8x minus 6x is 2x. Negative 24 minus 18 is negative 42 equals 2. Let's solve for x. So plus 42 plus 42. 2x equals 44. Divide by 2, divide by 2. X is equal to 22. One more example. Given that f of x equals 6x plus 6 over x, find all values of x for which f of x equals 5. So remember, when it gives it like this, it's telling you the answer. Or you can think of it also as set equal to. So this is telling us that f of x is going to be 5. Or in another sense, we're going to set our function equal to 5. So that I have 5 equals x plus 6 over x. And this is what they want us to work with. So here we're just getting a little bit of a idea of function notation. Okay. Now, since we want to find all the values, let's go ahead and solve. Well, if we think about it as something just like this, it's like the problems we've been working with this entire section. So let's go ahead and solve for x. Let's multiply both sides by our LCM, and in this case, it's just x. Let's multiply by x's so that I can get rid of those fractions. So x and x are 0, and then we're just left with a 5 times x on the other side. So 5 times x is 5x is equal to x plus 6. We subtract x, 4x equals 6, divide by 4, divide by 4, x equals to 6 over 4, but this also simplifies to be 3 over 2. And that is our answer for this problem. Alright, that's it for section 5.5, and your homework is posted on my math lab. Thank you.